Hello everybody, this is Dean Hoffman, and today I want to talk to you about decision trees. And I'm going to use a specific use case, which is for people that are in sales or sales management or any firm that would manage salespeople or marketing strategies for that matter. And it's a way to optimize your outreach. The problem basically is if you've got thousands of people to potentially contact, you don't necessarily know who are most likely to convert into customers. And if you call all of them, that's very time consuming. It might not be cost effective. What would be ideal is if there was a way to narrow that list down to only those people that were most likely to convert to customers and have a data-driven way to do that. That's what I'm going to demonstrate today. I'm using a Dataset from Kaggle, which is from a web education firm, and not entirely sure if it's real data or not. It doesn't necessarily matter. It might be. It doesn't necessarily matter if it is. It was publicly available data, and it's a great data set to show how lead scoring can work. This can be applicable in many different industries, from manufacturing, equipment breakdowns, to medical outcomes. But today I'm going to focus on lead scoring. So let me first talk about a little bit what decision trees are in case you don't know what they are. If you're already a skilled machine learning people, this is going to be pretty basic to you. But for those of you that don't really even know what a decision tree is in machine learning or how it works, I think a good example, a good human example, is to think about getting married. Basically, when somebody gets married, they very likely probably go through some kind of a decision tree in their mind. For example, am I in love with this person? That's going to be part of the decision. That's probably going to be one of the key parts of the decision. Maybe after you've decided yes or no on that, the question might become, what kind of financial stability does that person have? Do they support my goals? This here is an actual mock-up of a decision tree. This is not real data. I want to emphasize this was generated data. This doesn't represent actual responses. Just to give you an idea, the decision tree will find at the very first, at the top level, it will find the single most decisive factor in splitting the data. So in this particular case, let's say you've got 100 samples. The single most deciding factor about whether or not they got married was if they were in love. A 0 would have been no, and a 1 would have been yes. Here you can see if it's less than 0.5, that would have meant a 0 or no. So if they were not in love, out of this 100, we know that 66 got married, they were in love, and 34 didn't. But what if they were not in love? Now all of a sudden there's 44 in this group, and only 15 of them got married, 29 didn't. However, what if the financial stability of one of the partners was very good? So that's true. And in that case, brought it down to 25 people in the sample, and 15 of them got married and 10 of them didn't. So you can see the blue boxes are starting to increase the likelihood of getting married. So what if on top of that, they have similar values? And in that case, out of 12 people, all 12 of them got married. So somebody did have financial stability, they did have similar values, and in that particular case there were 12 of them, and all 12 of them got married. You can see on this side there's many more blue boxes, and that's because these were people that were in love. So if they were in love, you had 56 of those couples, and 51 of them got married right out of the gate. But what if they were in love and they felt that their partner supported their goals? Now you had 31 people in that group, and all 31 of them got married. Sense of humor, similar values, financial stability, emotional support. So again, this is not real data. This was generated data, but it gives you an idea of what a decision tree is. The thought process that goes through people's minds and the data points that ultimately decide whether they get married or not. This is very applicable to what we're talking about with lead scoring and how it can benefit a business. It's the same kind of a process. So with the data source that we have, by using this kind of decision tree machine learning, we were able to show an increase in conversions from around 30% up to 85%. We're not sure if that's real data or not, but that's certainly the real test results from the machine learning. The challenge is, let's say you get 100 leads coming in, but only 30% of them are converting. So 70% of the time is lost. And what we want to focus on here is, let's see if we can get the 80% or more of these people to convert. In this particular case, we actually got up to about 85 of the leads converting. We were able to score and predict who would convert into a customer. The problem with traditional lead scoring, you've got wasted time. Salespeople spend hours pursuing leads that never convert, guesswork, using intuition to score models, revenue loss, high customer acquisition cost. If you're going through, particularly for firms that are doing in-person visits, if you're visiting a whole bunch of people that aren't converting, your costs are going through the roof and you're not really getting much back from it. And the other thing that's an issue is burnout with salespeople. If they're going through massive number of leads that never convert, they're not going to be very happy, and your turnover with them and their burnout rate is very likely going to be very high. So the problem with the traditional approach, you can either rely on gut feel and basic demographic data, or you can use machine learning to identify patterns. You can contact every lead with the same priority, or you can prioritize leads based on conversion probability. With this traditional approach, there's really no way to predict the ROI. Here we have a method to impute what the ROI may well be from the approach. If you're doing it this way, you've got static scoring. It doesn't adapt to the results, whereas this model using machine learning can continuously learn and improve from results. To talk about the approach and the validity, what we do is take a large pool of data, in this case thousands. You will split that data and take 70% to learn the patterns from. So you learn what caused customers to convert and what didn't cause customers to convert. You take 70% of that as the training data. This is very important to keep in mind. Then the 30%, you don't let the computer see, that's blind to the computer. So after you build your model on the 70% and it looks really good and you think you've got something, then you apply it to the 30% that the computer's never seen, just to say, okay, how well do you work on new data, stuff you've never seen before, which would be the equivalent of how well will you work tomorrow, even though you look like you worked good in history, how well will you work on new data that you haven't seen before? Let me give you an idea of the data that was used. So this is a spreadsheet with the data that came in. You had the lead origin, the lead source, whether or not they didn't want to be called, the total times they visited the site, the time on the website, the page views on the website, the last thing that they did, the country they're from, what kind of industry they're in, how they heard about the company, what their occupation is, all kinds of data that we have. Where did the lead come from? Search, magazine, etc. We've got all of these different potential things that could be used to help predict whether or not the customer will convert. Now, a lot of times the data needed to be cleaned up rather substantially. So let me just go back to how we did that. So this is a little bit of Python code here, and I'm just going to do a quick demonstration. This file was lead scoring, which I'm going to need to close to do the analysis work. We are going to run some cleaning on it, and you'll see a new file appear after I'm running the cleaning on the data, and now we've got this clean data, which got rid of some columns that shouldn't be in there, cleaned up the data, maybe filled in missing values and that sort of thing. And then the next thing we want to do is run the decision tree model. Just like I showed you in the marriage example with the tree with all the nodes, we actually want to run that model on all the data. It's interesting to see how intensive this is on the computer. So there's our CPU usage right now, about 53%. When I say, okay, train this data, you can see it's running. And bam, you can see the CPU usage go straight up to 100%. And it's going to be there for a little bit. It's going through a lot of data and checking a lot of nodes, a lot of considerations. And it's going to finally give us a result here in a minute, hopefully sooner rather than later. It shouldn't take too much longer. Got the CPU maxed out at 100%. And this is a later model chip, an i9. This is a pretty powerful chip. So even at that, it's got a lot of data to process. Okay, there we go. Finally done. Thank goodness. And now you can see the CPU usage falling back off. It gives us a summary of, and I won't go into this too much because it'd be a little bit maybe too technical, too boring, but it's basically showing us that our predictions got up to about 85%. And it also showed us what the most important features were that decided whether or not a customer converted. The most important thing was the time they spent on the website. The next thing was the last activity that they had. The next most important thing was page views. It is weighting what the single most important thing is. Just like with marriage, love was the single most important factor. In this particular case, it was the total amount of time that the person spent on the website that had the most impact on whether or not they converted. Let me go back to presentation. You were looking at a little bit more detail, but we went from that roughly 30% conversion rate up to 85%. And accuracy is basically how accurate the predictions were and how much of the data we got. You don't want to say, yeah, I predicted 10 of them and all 10 of them were right, so I've got a 100% rate, but you missed all the other data, so you don't know what you missed out on. So recall's looking at how much of the total amount could you have got, did you got. This was the total, 3,408. These were the top 3 predictive factors, even though there were other predictive factors. What can be done after you have these top 3 is you create a couple of specific files needed for analysis. This is the actual decision tree. I won't go into great detail on this. That's something that you could look at later, and it goes many levels even deeper than this. But you can see here time spent on website, just as we talked about, was the #1 decider in whether or not the lead converted. We can run the decision tree and look at it. I create a few more files that we need. What's interesting is we can start to look at where our stopping point on the leads is, where our maximum payoff with these leads are. And let me explain what I mean by that. What we are now predicting is the likelihood that they will convert into a sale. So in this case, this first lead here has a 100% likelihood that it will convert into a sale. The next lead only 99.5, and so on and so forth for thousands of customers. And you can see as I scroll down here, the likelihood that they'll convert keeps getting lower and lower. So the question is, where is the optimal point? In other words, do you want to spend your time calling customers that have a 0% predicted probability of converting? Because you have a total cost that's fixed. Every time you make a phone call or visit, you have a fixed cost and it doesn't change whether that customer converts or not. In this case, I've got it set to $50, the fixed cost. So the first one is $50. Your second visit, now you're up to $100 because you had 50 more. Your third visit, you're up to $150, or a third phone call. This total cost keeps increasing. Now, I've got the profit if you make a sale at 200, and this one's got a 100% likelihood of predicting, so I'm going to show that profit as being 150. You've got the $200 sale minus the $50 cost, so you've got a net profit of 150. Now, the next one has a 99.5% chance of converting, so the profit is not going to be the full $200. We're going to compute that profit on that is 199, since it's only got a 99.5% chance of converting. And I realize that's not specific, precise math exactly what would happen, but it's a proxy. So it allows you to weight things. If you go down to where there's only 60% chance of converting, even though it's a $200 sale, we're going to call that 129 because it's only got a 60% chance of converting. I know this might seem a little bit confusing right now, but if you start looking at, okay, I'm racking up total costs as I go, which is fixed. It just increases at a fixed rate. Cumulative profit, this is going to be based on how much profit I make per sale, and that's going to be dependent on what the percentage likelihood of the conversion is, and then that's going to give you a net profit. So this is what's interesting. This chart shows in blue where you're making money and then where you start to lose money, where your fixed costs exceed what you're taking in. If you've got a $50 cost per lead and your sale is $250, your $50 per cost per acquisition, and $250 is what you get from that acquisition. What it's showing you is that you only want to call about the first 2,000 leads, because even though you've got 6,000 leads, you're actually beginning to lose money calling these leads because their chance of converting is getting lower and lower, whereas your fixed cost remains the same. Let's use a different example. Let's say that your total cost was only $10. Now this is many more leads you could call because your fixed cost is racking up a lot slower. Here you would want to call 4,000 leads out of the total of 5,600. Profit all the way up at the top. You're going to want to call nearly all of them, but not all of them, because you do have some that have a 0% probability of converting. So you don't want to waste your time with people that have a 0% probability of turning into customers. From a technical standpoint, what I'm using here is a very interesting plugin called Dash, which if you're using Power BI, Tableau, you ought to look into it because it's basically free. It has a lot more flexibility in how you can chart things out. But let's do one more example to give you an idea. Here you can see, here's one where your fixed cost is $30 per, and your profit per sale is your revenue is $150. And here you can see where your line stops. So this is your stopping point. By scoring these leads and knowing your cost and projected revenue, you've got an idea that, hey, even though I've got this many leads, I only want to contact this many of them. So when your salespeople get in during the day, you're only having them focus on these leads that have been given the highest percentage probability of converting. If you just looked at the total amount of leads, you might think I need 10 salespeople to cover that. But if you realize I'm only going to be calling this many, maybe you only need 2 salespeople to cover that. Your expenses go down, your closing ratio goes up, your time to acquisition goes down. Lots of benefits from lead scoring. I just wanted to give you a quick presentation on that and show you how that works. I'd love to collaborate. If you've got any ideas on that or questions about it and want to contact me, by all means, please do. So that's it. Thank you for your time today. I hope you found that interesting, and I'll be talking to you soon. Thanks.